Okay, so I want to use I'm going to use Desmos to show you how to graph a point if you need to do this manually. Um, but normally, we're used to graphing a point on a rectangular grid. All right, so you do your x coordinate, you got your x-axis, your y-axis, you go horizontally for x, vertically for y. So like I said, dealing with polar is different, where you do the distance from the origin and then the particular angle. All right. So if you saw this, this is the same point, rectangular coordinates. Look at it in polar with a polar grid. So R is represented by, they use circles, and these circles are they represent the radius where the origin is the center. So you see how, from 0 to 2, okay? So in this case, the R coordinate is 2. And then the angle I have, I put in pi over 4, which we know is pretty much the halfway point. It's 45 degrees. It's halfway between 0 and 90. So it should be right here. And here, if I labeled it, this would be pi over 4, okay? All right. So if I wanted to do, maybe I change from R to 2 to watch the transformation. So keep your eye on this point right here, okay? I'm going to change it from 2 to 3. Now it's on the circle with the radius of 3. And if I make it 4, now it's on the circle with radius of 4. Still on the same line because I haven't changed the angle, okay? So I'm going to go back to 2. Now, if I change it from pi over 4, let's say I make it pi over 2. You see how I'm at this point due north right here? Maybe I want to change this now to 3 pi over 4. So I got the point 2, 3 pi over 4 right here. Okay. So this is the point. Remember, in polar coordinates, it's 2, 3 pi over 4. Okay, and that would be there. All right. Now, what makes polar coordinates different from rectangular coordinates is, think about the point. Maybe you want to graph the point -2, 3. There's only one way to express that point. There's no other way you can express -2, 3. That one location only has one point. However, polar coordinates, we actually have infinite number of representations. If you remember, you go around one revolution. Again, we saw this back in the beginning of the course. Every time you go one revolution, you end up at the same spot. So going one revolution means you're going around 2 pi, or if you're in degree, you can be in degrees for this 360. So let's say I'm at the point right here, 3 pi over 4. I want to go one revolution around, so I'm going to add 2 pi. Which means for this, if you do 3 pi over 4 plus 2 pi, I'm going to be at 11 pi over 4. You see how I'm at the same location? Okay. All I did is I went once around, okay, to get to that spot. All right. So I'll go back to 3 pi over 4. Now, of course, you could always go in the negative direction. Let's say I go clockwise, which means this time I'm going to subtract 2 pi. That's going to put me at -5 pi over 4. And once again, you see how I'm at the same point? Okay. Now, one other thing you're going to see is we can actually make R negative. But watch what happens here. So I'm at 3 pi over 4. What if I make R -2? Watch where the point goes. See how it went halfway across? All right. So it actually refers you to the opposite side. So it was on this line right here. This is the line 3 pi over 4. But in reality, when you make it negative, it sends it to the opposite side, okay? So to counteract that, okay, I want to represent this point again, 3 pi over 4. Well, if I make R negative, I actually have to go halfway across the circle. So that means you got to add pi, okay? That's going to put me at 7 pi over 4. Now remember, 7 pi over 4 is supposed to be right here. But look where the work I'm referring to now. So this is just another way. If I make R negative, I have to refer to the angle on the opposite side, okay? So -2, 7 pi over 4 is another way to represent that point, okay? So that's how you graph, that's how you find points, and also finding other representations of that point.